Hey folks, this is a lesson on section 8.3 and how to get the coordinates of the unit circle. So if you'll go down to the actual unit circle, I'd like to take a look at a couple of things here before I get started on my triangles. First of all, a unit circle is called the unit circle because the radius is equal to 1. So let's get the easiest coordinates first, the ones that are on the 4 axes. You know that if I have a coordinate right over here and my radius is equal to 1, then that's going to the right 1, and I have no y value, so that's going to be a 0 y value. Go up to the 90 degrees or the pi over 2 position. Here we have 0, 1. Over at 180 or at pi, I have negative 1, 0. And then down at the bottom at 270 or 3 pi over 2, this is going to be at 0, negative 1. These are the 4 easiest coordinates to come by. Next, what I'd like to do is take a look at all of my spokes. So this is going to be the places where I have either 30s or 60s, any kind of pi over 3 or pi over 6 positions. In order to talk about this, let's go back up to the top where I have a 30, 60, 90 triangle pictured for you here. Notice that the hypotenuse is 1, and the reason that the hypotenuse is 1 is because this is going to become the radius on the unit circle, which is also 1. So I'm going to be matching this up. Notice that my triangle definitely has a short leg, and it also has a long leg. You can tell this visually. By the way, a short leg on any triangle, not just the 30, 60, 90 triangle, but a short side on any triangle is always going to be opposite the smallest angle. So if I have pictured here my shortest side, then it's always going to be opposite my smallest angle. So the shortest side opposite the 30 degrees in this particular case. Now, in the 30, 60, 90 triangle, when the hypotenuse is 1, one of the things that we're going to see is that the short leg will always equal 1/2. If I were to do the Pythagorean theorem to find the missing leg, I'm not going to run through that. You can take a look at that on your own time, but here it is. And so I can see that my long leg, the missing side, is going to be √3 over 2. So in the notes, you see some fill in the blank. If the hypotenuse is 1 on a 30, 60, 90 triangle, then the short leg is always going to be equal to 1/2, and the long leg is always going to be equal to √3 over 2. So let's put this into practice down on the circle. Let's take a look at the very first spoke that we have here. And I'm going to go ahead and draw a triangle, and I'm going to lighten the color a tad just so that it's not so vibrant. So here's my x value, and then here's my y value, coming to a right angle there. Here is my hypotenuse. Once again, that hypotenuse, or the radius, is going to be equal to 1. And I think you'll be able to look at this green triangle and definitely see that there is a long leg and there is a short leg. The long leg is my x value. So remember, the long leg is the √3 over 2, and the short leg is my y value in this case, so that's going to be a 1/2. If you'll go over to the other pi over 6 positions, you'll see the same thing. So let's go all the way over to the second quadrant at 5 pi over 6. Notice here that the short leg, let me draw my triangle, is my y value. My short leg is my y value. My long leg is going to be my x value. Now remember, in the second quadrant, x value is always negative. So I have a negative long value, negative √3 over 2, and I have a positive short value because it's going up. Let's go to the third quadrant where I have another pi over 6 position. And this is going to occur at the 7 pi over 6 position. Once again, I have to the left a long value, so that's going to be a negative √3 over 2, and then going down a short value, so that's going to be a negative because it's going down 1/2. And then the last pi over 6 position that I have is in the fourth quadrant at 11 pi over 6. Notice that I'm going to the right a long leg, and then I'm going down a short leg. So to the right is root 3 over 2 long leg, down negative 1/2. Now these are not the only 30, 60, 90 triangles. The other spokes are also 30, 60, 90 triangles. So let me change the color of my triangle here. And in this particular case, once again, let's draw the radius. Let's come down to the x-axis. And then there's my x value. In this particular case, you'll notice that now the x value is the short value and the y value is the long value. So if my x value is a short value, it's going to be a 1/2. My y value, the long value, is going to be root 3 over 2. The next pi over 3 position, same thing, only this time it's my, once again, my y value is my long value. My x value is my short value. But this time my x value is negative, so we're going to the left, a short value, that's negative 1/2, and we're going up a long value. Come down then to the third quadrant. Let's take a look at the 4 pi over 3 position. You're going to go left a short value, that's negative 1/2, and down a long value, negative root 3 over 2. And then go to the last pi over 3 position. This is your 5 pi over 3 position. And so you're going to go to the right a short value, that's positive 1/2, and down a long value, negative root 3 over 2. So that shows you all of the 30, 60, 90 positions, 30, 60 positions, the pi over 3s and the pi over 6s.